Hello everyone, welcome back. In this video, we will cover the basics of data visualization, which includes some basic plotting and aesthetic mapping. On your first day as an intern, Director Tim would like you to visualize some of the data and identify any potential trends. Let's get started. First, let's open the IMDb movie rating CSV file in RStudio and name it as IMDb. As usual, we will put IMDb first as an object and use the assignment sign, the alternative dash, read.csv, open bracket, and then IMDb movie rating CSV file, and then comma, header equals to true. And then press run. And then you would see the IMDb data frame is available in your environment pane here. Alright, if you want to have a look in the file on what's about that, what's the data inside, so you can just press IMDb or use the view or glimpse function, and then you can see all your variables here, your data available here, and etc. etc. Alright, before we proceed, remember that we will need to load the packages before we run the commands. For visualization, you may load the Tidyverse packages by pressing library and then to load the Tidyverse package and then press run. This will include a collection of R packages including ggplot2 and dplyr, or even if you want to be more specific, you can just run library and then load the ggplot2 package and then press run, and then you are done. Alright, now Director Tim would like you to make an overall scatter plot for IMDb score and also number of awards achieved for all the movie they have. Let's do it step by step, alright? So I've included a graphing template here as your reference. So this is the common terms where we will be using in this tutorial. So we just use like ggplot and then data equals to your data frame, mapping equals to aesthetic, AES, and then put your mapping inside. So for example, like x-axis, I want to put this, y-axis, I want to put that, or if I want to insert some colors into the graph, and etc., we will use aesthetic functions. And also after that, not forgetting to add another layer of geom functions. Alright? Just a note here, as ggplot has a very specific syntax, we will need to create the graph layer by layer. So let's get started. Imagine this as your high school maths class back then when you are still using very traditional pen and papers to plot a graph. So first, you will need to prepare a graph paper, right? So this will be an analogy of how R works as well. We will need to create the first layer of graph first. We start with ggplot and then open and close bracket and then press run. You would see something like this. Alright? So don't forget, we will need to tell R that actually my data is under IMDb file. So R can actually recognize that, okay, I actually want to run that under that data equals to IMDb. Similar to ggplot, you would see this is a very clean template that it's like an A4 paper. You can see it's in a blank state as you have not specified any mappings or specified any variables yet. So just to remember that you insert your data to let the R know first. Alright? So next, try to create your X and Y axis. Back then, we will need to take out all your pencils, pen, rulers, eraser, right? And sometimes your ruler might not be long enough and like your line would be slanted and etc. But in R, we can totally forget about this issue. we just need to use the mapping function and tell R to put your X and Y axis. Alright, again, we use the ggplot. So we just copy this. ggplot data equals to IMDb. Now I want to map something, so I put mapping equals to aesthetic. Now I want X equals to score, and then Y equals to awards, and then press run, and you will see this. Alright? So X and Y axis already created for you. So now just copy and paste this function again. In order to plot some of the data in your graph paper, so back then we need to use like pencil to plot one by one according to data and then try to be specific in the graph paper and stuff. But in R, we use the geom functions. So we just put this and then we just plus, which means add, and then geom point, and then open and close bracket. Just for your information that geom point is usually the command we use to get a scatter plot, and then a graph will be generated within a few seconds. Alright, and ta-da! As for this command, we will use like, this is a very basic scatter plot we have already done. So you can see everything is already here. So let's copy this whole chunk of command here. So we can kind of keep on repeatedly using it rather than keep typing it the same thing lah. Alright, so now let's try other variables instead. So let's do some practices. We use, instead of IMDb score and awards, let's do IMDb score and views. Let's just paste the command we have copied earlier and change, since the score is similar, so we just change the award into views, and then press run, and then you would see this. So next, similar, also paste the same command and then just change to number of country, and then Y equals to view, and then press run, you would see this. And then last but not least, we go with number of country available and award. So change to number of country, and then find the awards, number of awards available here. So we just run. You can see a scatter plot shown here. So if you want to see the overall what we have run, we can just use run current chunk, and everything will be generated here, and you see which one we kind of transition from a clean graph to R to X and Y axis with score and awards, and have a scatter plot done, a very basic one, and then have different type of plotting according to different variables, and you would see all this. Alright? And we're done. So next, director Tim Timothy feels that the graph is a bit boring here. He would like to put in some colors into the score and award graph. Instead of the default black, let's change to blue instead. Alright? So still remember the command we have copied just now. So we just paste it again. But now we incorporate colors into the geom point function. So in geom point, we use color equals to blue. Remember the open and close inverted comma, and then we just press run, and then you would see, oh wow, so instead of a black dots, and then we can see a blue color plotting here. Alright, so how about other colors? So let's just try this again. So we just include color equals to red, or even color equals to turquoise, and then just press run. And then you would see a different color of plotting here has already generated. Okay, so blue, red, turquoise. But if I'm not sure about the name, or like I want to be more specific, is it possible for me to include a hex code instead? Yes, the answer is yes, and you can just include as usual ggplot, and then we just put color equals to, instead of the name, we just open and close inverted comma with a, remember the hex code started with a hashtag, so we put 00ff00, and then let's see what's the color have generated. Alright, so press run, and then you would see, oh, okay, so green color's hex code is 00ff0. So you can always Google about the hex code on what specific color you want. So this is an example of green color hex code lah. Alright, so just another reminder here is that to make sure your color is always at the open and close inverted comma, otherwise you would see like, then you would see an error command, so error in layer here, and then object red is not found. So if we don't want this, we just ignore this part and then just press run everything, and then you will see all the color of plotting here. Alright, how about putting some gradients on the awards in existing mapping? So let's try to put some more interesting color or even gradient here. Okay, so paste again the initial very basic command. So now, because we want to put in some color into the plotting, right? So we need to put that in the aesthetic function. Okay, so in aesthetic function here, we just add another section like a column, a comma, and then we press like color equals to, so we want to plot against the award function, the award variable. So we just put award and then press run. So you would see there is a gradient here from a very dark blue into a lighter blue. So it actually is just a one color thing, but the gradient actually based on the value of your variable. So the higher the value, the lighter it is lah. So you can see how it become from different color into gradients, and yeah. So next, in order to adjust the size of plotting, you can even change that actually. So let's try to adjust this by changing the size of the plotting. Alright, so again, back to the very basic command, and then now we just put like, since we want to remain like the color, for example, color equals to blue, and then we just add, I want to change the size, so size equals to 3. Alright, so we just press enter, and then you would see, you can see like this is like a bigger plotting, right? So if we want to change the size into 1, and then we just press run, you will see the plotting is actually smaller. Alright, it's actually able to function without this color, so we just press run, and then you would see a general default black color scatter plot here. Alright, now let's go into some aesthetic attributes here. Alright, instead of looking at the general pattern of from the overall graph, director Tim Timothy would like to have further details of current data based on genre of movies. As there were a few aesthetic attributes here available, you were unsure about which attributes to go with, therefore you plan to explore across each aesthetic attributes lah. Alright, so what aesthetic attributes we have actually is that we have color, we have size, we have alpha, we have shapes. So just now we were looking at the score by awards. by including the colors. So now let's include the genre into the graph. So starting with color. So again, paste the very basic command, and then now we add color equals to genre, because director team would want the genre, right? So we just press run, and then you would see this. Okay, wow. So instead of like one color graph, that is different types of color according to genre, according to the plotting itself, and yeah. So other than that, let's try to use size instead. Okay, so we just copy this and then paste. We just change the word from color to size, and then you would see this. So you can see like different size of plots according to different genres. And then next, go with alpha. So just change the size into alpha, and then just press run. And then you would see there are like different transparency according to different genre. But you can see here there is a warning sign that using alpha for a discrete variable is not advised, because like it's a categorical variable, but you can't really differentiate between the transparency itself lah. So even for size, right, you can see there is an error bar. Using size for a discrete variable is also not advised, because it's really hard to see. Even the plots are also a bit overlapping, so it's kind of confusing as well. So last but not least, let's try shape. Alright, so you can see this, there is different number of shapes and like all this, but you can see the documentary, drama, horror, mystery and thriller, there is no shape here. So when we see our console here, it has stated that the shape panel can deal with only a maximum of 6 discrete variables, but in our context, we actually have 11 genres. So either we manually put in different type of shapes if we really want to have them. Otherwise, R will actually remove 24 information that contain all these missing value according to geom_point functions lah. Alright, so if we just run current chunk and we see everything here, and then you would see the difference between color, size, alpha, and also shape, and they will show you all the warning sign to let you aware that what's the potential issue. So with the high amounts of different genres, color seems to be a better choice here due to the limitation of other attributions such as shape and sizes, while alpha does not seem to be really helpful either. Alright? So that's all for part 1 of our data visualization part 1. So let's take a 5-minute break, and we will come back with a more advanced function such as faceting and also other functions.